Okay, so your homework was try 13 part B, part 3, A minus B minus V. Okay, so let's try doing this together. Let's start with A minus B. So this from A to M. This is my vector A, so this is my start. Then we minus B, so I go backwards, right, for the vector B. So since B starts from B and ends at M, I shall go backwards. This is now my negative B. So I've got A minus B done. Now I need to minus V. Yeah, so I've mentioned earlier to include this portion that DECB is a parallelogram, which implies that this DE is the same as BC. Okay, so same magnitude, but okay, so DE and BC, they have the same magnitude, they have the same direction. Now I want minus V, so I need to go in this direction for the same magnitude. So this will be negative V. Okay, so in summary, my start from here, I want to end over here. This is the end. Which vector in the diagram is the same as that in blue? Which one? Can you spot which one is the same? DB. So the answer will be DB. If you draw it to scale, you will be able to see it quite clearly. Can? So let's move on to next one. Example 14. We try it together. Here I have a triangle with a point T inside. TA is vector A, so on and so forth. Express BC, CA, and AB in terms of AB and C. Okay, so let's start with BC. I want to start at B, and I want to end at C. What is one way to go from B to C using a combination of the identified vectors given to us, A, B, and C? Okay, you don't look at the answer. The answer. Wait. Black highlighter. Okay. Not difficult anyway. Just try it by yourself. What is an alternative route to go from B to C, but by using a combination of the yellow highlighted vectors? How to go from point B to point C? Start. Obviously, we want to go from B to T, right? So what is this vector called? Okay, so we'll write BC equals to BT. Alternatively, some of you very quickly you can see that it's actually negative B, isn't it? That's the question. BC. Okay? So that's B to T, then T to C plus TC. Okay, alternatively, you can skip this step and straight away write down this negative B plus C. Easy? Okay, what about CA? So think about it mentally. Tell me what's the answer? C to A. So that will be negative C plus A. Yes, you are right. So this is negative C plus A. And last one, AB. AB? Negative A plus B. Okay. Who cannot do that? Anybody cannot do that? So just know that when you flip the vector, same magnitude, opposite direction, just put a negative sign. Now, express B, C, C, A, B as a single vector. What does this mean? B, C, B start to C, C to A to B as a single vector. What do you think the answer is going to be? 0, yeah, it's a 0 vector. Because we start and end at the same point, right? Okay, The other way of looking at it is that all the intermediate points are the same, so they will cancel. So this is actually BB, right, which is 0. Alternatively, we saw that BC is negative B plus C. Then we've got AB is, no, CA first. So CA is negative C plus A. And finally AB, negative A plus B. If I add everything up, negative B plus C minus C plus A minus A plus B. Okay, do this mentally. What do we get? This one? What do you get? Yeah, it is 0, right? So they all tell us the same thing. When you start and end at the same point, you will get a 0 vector. Okay, so try it. 14 over here. Okay, part A. This one you all should be able to do. BC is equal to minus B plus C. And the next one, dA equals to negative D plus A. Alright, now this is the part that some of you need help with. This piece of information was not used yet, so I'm going to use it now. AD equals to BC. Agree? Okay. AD, what is AD? Wait, what is the, how can we express this AD in terms of these little vectors? AD. Minus A plus D. Yeah, alternatively, we can actually obtain it from here, right? So we just switch the signs. So I get D minus A equals to BC. And what is BC? Negative B plus C. Okay, now I have an equation involving all these. I want A and C on the left hand side. Huh? So D minus A equals to negative B plus C. Group all the A and the C together. So D plus B equals to A plus C. So A plus C equals to B plus D. Shown. Wait, one by one. Yes? Switch the signs. Yeah, because I'm switching the sign because we are saying that AD is the same as DA, but in the opposite direction. So I switch all the signs. Yes, Francis? So can do, right? What is your question? Yeah, you cannot. You only can switch when you put a negative sign. So this over here allows it to be done with a negative sign. Okay, now scalar multiplication, we will see that it's going to be very similar to our matrix multiplication again. Okay, so this over here, I've got a vector A. What does the vector 3 over 2A look like? So if this is A, then 3 over 2A must be actually A plus half A, right? A plus half A. That's how we get 3 over 2A. So half of this is over here. This is half A. So I'm going to add this half A to itself over here. So the entire stretch from this start to this end will be 3 over 2a. Understand how this works?
So half.
Yeah, half, 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 if you want to look at it that way. Okay, it's just a multiplication. Now, when I multiply a scalar, this one over here, this 3 over 2, is it a vector or scalar? 3 over 2, vector or scalar? How do we decide? Does it have a direction? Does 3 over 2 have a direction? No, it's just a number. It is a scalar. When I multiply a scalar to a vector, what is my result? It is still a scalar times vector. Ultimately, it is going to be a vector. This is a vector. Okay? So originally I had vector A. I multiply it by 3 over 2. I get my result, which is another vector. Look at their directions. Are they the same? Same direction, right? What about the magnitude? Same or different? Different. So when I multiply a scalar with a vector, the only thing that changes is the magnitude. Alright? Is there a possibility that I multiply a scalar and then the direction change? Is there a possibility I multiply a scalar, then the direction change? Possible? This is my vector A. Okay, consider what happens if I, for example, I want 2a. What does 2a look like? Times 2, okay, so I go out this way, right? Okay. So this is 2a, am I right? What happens if I multiply 0 with a? So what do I get? A 0 vector, right? So there's nothing to draw. What happens if I go the other direction? Let's say I multiply -1. -1 times a. -1 is a scalar, it's just a number. -1 times a, we all know that it's going to give us -a. Does the direction change? What does -a look like? Yes, right. It looks like this. -a. So it is possible to change the direction when you multiply a vector with a scalar, if the sign is different. Now, when we say change direction in this case, it is still going to be parallel. It's just opposite direction only. It cannot rotate. Rotation, translation requires you to add vector. In this case, we multiply with a negative, so the direction will either be the same or it will be opposite. In both cases, they are still considered parallel. Won't be learning here. Okay? Now, the other direction, we've got, from here, this is the same one, vector A. If I multiply with a -half, so we see the A, actually it changed direction. It flipped, and in addition, the size, the magnitude was halved. So we can also multiply by a -2, magnitude times 2, vector direction opposite. Can? This is called scalar multiplication. So for any vector A and Ka, they are parallel to each other. Please include at this point, parallel can be 1, same direction. 2, opposite direction. These are the only two possibilities. Can you please include it in your textbook? Okay, next. Here we have more relationships. Let me repeat. They are very similar to what we have already learned. U and V, they are vectors. M and N, they are real numbers. So this part, scalar. This portion, vectors. So when I take M plus N, scalar plus scalar, so number plus number, multiply with a vector, then you can do your distribution again. Like a rainbow method, you get m times u plus n times u. It is exactly the same as your rainbow expansion. Then we also have a case of m, a scalar multiplied by a combination, or in this case an addition of two vectors. Again, we will expand them out to be the same. Okay? Then we need to consider what happens when it is the vector written in this form. Because vectors can be written in this way, a, b. It can be, for example, let's try another one, k. It can also be written as x, y. There are a few ways that we can express vectors. If we are using a column vector, we multiply by k. This is the answer, just like our matrix multiplication for scalars. Okay, so let's practice. Let's not do example 15 because I think you all know how to do it. Let's do try 15, 3 minutes. Now we have two vectors over here, P and R. P is well defined. I know it is 3 units to the right, 6 units downwards. R will be m units. M can be a positive, can be a negative number. So I don't know whether I'm moving right or moving left, but R will require me to move upwards 4 units. Can you understand that from the question, first line? Okay. Now these two vectors are parallel. Oh, okay, what does this mean now? They are parallel. So are they in the same direction? Yes, no, or maybe? Maybe, right. Because they can be the same direction, they could be opposite direction. In both cases, they are still parallel. Okay? Then we are now required to find the value of m. When two vectors are parallel, can you flip back a few pages? Show me vectors that are parallel in your textbook. Okay, the parallelogram. What else? Something that we covered today at the start of this topic. This topic. Parallel vectors. Any? No. You're going too far back already. I said this topic. This one. Can you find parallel vectors? Yes. Right, all of them are, these four, they are parallel, right? When these four are parallel vectors, we notice that the only difference between them in their writing, in the way we write it, is the coefficient, right? Do you agree? Yes. As long as the yellow parts are changed, I get a different vector, but it is still parallel, whether it is in the same direction or opposite direction. So that is the effect of multiplying a scalar with a vector. You result in another vector which is parallel. Okay, so we are going to explore this effect in example 16. When I tell you that these two vectors are parallel, I am able to find out the value of m. Okay, but before that, I want you to try and discover the relationship. I'm going to give you a list of vectors that are parallel to each other. For example, 1 and 2 is parallel to 2 and 4. Okay, this is also parallel to 5 and 10. They are all parallel. Can you guess x and 12? What is x going to be if they are all parallel? What is x going to be? Value. If these are all parallel, what is the value of x? 6? Yeah. How do we get 6? Okay, let's rewrite this to become 2 and half. Correct? So this is what Sophia did just now. So this becomes 5 and half. This has to be 6 and half. Okay, so we see that. Why am I writing a fraction? Shouldn't be a fraction. Okay, I made a mistake. These are vectors. So we see that all these are the same vector. The only difference is that it has a scalar multiple outside that cause the magnitude to be different. but the resulting vectors are still all parallel. Okay, and I can also add on to say that these vectors are also parallel to this. Get it? They are all parallel. Even if I put a negative sign, because the direction changes, but they are still parallel. Okay? So let's make it a little more complicated. If I've got a vector 4 and 6, I say that this is parallel to the vector 3, let's change it to become x and 8. Okay, what is x going to be? Think about it. Came from similar triangles, but presentation wise we don't have to use that on the board. As long as I know a vector, I know that two vectors are parallel, for example A and B are parallel, then I know that A must be equal to k times of B. Okay, as long as they are parallel, A must be k times of B. This is the same as this one. Okay, because they are parallel, one vector must be a scalar times of the other vector. So this is our first step. Since they are parallel, we write down 3 and negative 6. Just copy down one of the vectors. So we copy down P is equals to k times of the other vector, k times of m and n, and 4, sorry. So this is the forming of equation. You get 1 mark for this, if they are generous. Forming equation. And we write this down because they are parallel. Please highlight this step. This is the key to solving it. So now that I have a vector equals to k times of another vector, then we can do our scalar multiplication, just like our scalar multiplication for matrices. So my 3 and negative 6 stays the same. The k is multiplied into m, and it is multiplied into 4. So I've got km and 4k at the top and bottom respectively. So since these two vectors are the same, 3 must be equals to km. At the same time, negative 6 must be equals to 4k. This is a set of simultaneous equations where you have two unknowns with two equations. Obviously, you should solve for k first, because negative 6 is actually 4k. So k is negative 3 over 2. Substitute into the first equation to get the value of m. Okay, so now we see that these two vectors, P is equals to 3 and negative 6, R is equals to m, we found it was negative 2. Negative 2 and 4. Okay, looking at these two, can you tell me whether they are in the same direction or not? Or opposite direction? Same direction or opposite direction? We do know that they are parallel, definitely parallel. But are they same or opposite direction? And then how do you tell whether they are opposite? Same or opposite? We can rewrite P and R. Let me rewrite them for you. P equals to 3, so 1 and negative 2. R is equals to negative 2, 1 and negative 2. Okay, now, does it make it clearer to you? Compare the ones in blue?
Yeah,
Different direction, right? Same, it is the same vector, but you've got a different scalar multiple. And because one is positive, the other is negative, definitely your vectors are going to be in opposite direction. Okay, so that is what this portion over here is trying to say. Since this is negative 3 over 2, it is less than 0, then they are in opposite direction. As long as the sign is different, it's opposite. So now to find the value of P over R. I want you to read this carefully. This P with the two vertical lines, what are they trying to get you to find? Starts with M. Magnitude, yeah. Magnitude of P divided by magnitude of R. So, magnitude of P, just use your Pythagoras theorem. Get it? Magnitude of R, again, Pythagoras theorem. Then you just divide. Okay, so P and R, Pythagoras, answer 3 over 2. So now please try it 16. Okay, 5 minutes for this. Refer back. Okay, so let me do that. Part A. B equals to K times of C. Negative 3, negative 1 equals to K, 6 and N. Negative 3 equals to 6K. Negative 1 equals to Kn. So 1 and 2 from equation number 1, K equals to negative half, sub into 2. Negative 1 equals to negative half times N equals to 2. You got N equals to 2? Okay, so now part B. Ratio of magnitude B. Okay, so let's find magnitude of B. Negative 3, negative 1. Square root of 3 square plus 1 square, square root 10. Next, magnitude of C. What is the vector? 6 and N. Okay, 6 and 2. This will give us square root of 36 plus 4, which is square root 40, which is square root of 4 times 10, which is square root 4 square root 10, which is 2 square root 10. So square root 10 versus 2 square root 10. The ratio must be 1:2. Any part you need me to explain?
So you don't get the number from it?
I don't need the exact value because I'm finding ratio. If you had evaluated this, then I'm sure you're going to get lots of many digits because it is irrational. Then you won't be able to get an exact ratio. Okay, are there other ways of doing it? Actually have let's see whether you prefer this. Okay, so in blue, B is equal to negative 3 and negative 1. Then I've got C, which is actually 6 and 2. So C can be written in terms of B, B can be written in terms of C. So I can put out the negative 3 over here, negative 2. So I get negative 3, negative 1. Am I right? That is C. Agree? Can see? Okay, so this means that C is actually equals to negative 2 of B, right? Then can you tell me the magnitude, the ratio of magnitude already? Which one is bigger than the other? B or C? Which one bigger? Which one has a greater magnitude, B or C? Hello, just need to stare at this one. C equals to negative 2 times of B. Which one is greater in length? C is greater in length. How many times? It is 2 times. Okay? Just note that they are in opposite direction because of the negative sign. But magnitude will be 2. Will be twice. Okay, example number 17. So here we have 3 different vectors. Then they tell us that actually C is made out of a combination of A and B, where M and N are scalars. So find the values of M and N. Okay, next type of question that you'll see, we write down the equation. C C equals to MA plus NB. Just copy down everything exactly as it is. Then you see that, hey, vector C is actually equals to, when you combine MA and NB, 3M plus 2N, M minus N. So this vector equals to this vector. So the x components, the numbers at the top must be the same. Then the numbers at the bottom must also be the same. For them to be the same. Same as your matrices, same as your vectors. So from here we will generate two simultaneous equations. 3m plus 2n equals to 5, m minus n equals to 5. Solve your simultaneous equation, get m and n. Okay? So we're going to try this over here. So as long as you can reach this, it's good. Next, example 18. Okay, this diagram, BM is U, BA is vector V, BC. BC is 2 times of BM. How do we indicate in the diagram over here? BC is 2 times of BM. Can you try? Indicate in your diagram that BC is 2 times of BM. How about this? To indicate that BC is actually 2 times of BM. So that B to M must be the same as M to C, which is U. So can you include that? Then at the back of your mind, you must also know that B to C must be 2U. Okay? Then we have AC is 2AN. Okay, AC is 2 times of AN. Oh, that means that this is N is the midpoint, right? And then we also have AG. AG is 2/3 of AM. Okay, this one over here. AG is 2/3 of AM. So which one is bigger, AG or AM? AM is bigger, okay, as shown in the diagram. AM is bigger, AG is smaller. So what is the ratio? AG to AM? If AG to AM is, okay, if AG is 2/3 of AM, what does that tell you about the ratio of the magnitude for the green one to the blue vector? What is the ratio of the magnitude? 2 is to 2 is to 3. All agree? 2 is to 3? Okay, if it is 2 is to 3, then what is the ratio of the green one, the green vector, to the red vector? If green to blue is 2 is to 3, what is green to red? No. Let me try again. Just now we said this is 2, and we said that this is 3. Am I right? So the green to the red, it will be 2 is to 1. Okay. This is what we need to do mentally. Can we do that? Okay. Next, express as simply as possible in terms of U and V, AM. Okay. So AM, part 1, is from this point. Start, and this is our N. We only get to express it in terms of V and U. So this is the puzzle symbol. This is minus V plus U. Okay, let's try the next one. AN. So this is our start now. And this is our N. Okay, how do we go from A to N? Half of AC. Am I right so far? It is half, right? This is half of AC. Then AC is actually AB plus BC, which is half of negative v plus 2u. You can leave your answer like that, or you can leave your answer like that. Negative half v plus u. Okay? Now about part 3, BG. Puzzle. It's a puzzle. So we say that BG is actually equals to B to M, then MG. Okay, so BM, we know that this is equals to U. What about MG? It is, MG is actually 1/3 of MA, right? Right? Then MA, we found that, okay, we didn't exactly find MA, but we know that it is actually negative AM, which was in part 1. Okay, so U minus 1/3, then you just substitute everything. Negative V plus U. So this gives me U minus 1/3 U is 2/3 U, then plus 1/3 V. You want to go from B to A then to G? Can. You will get the same answer.
So the substituent part, the one that has the other.
Yeah. Okay.